There was friction. We got told we were going to hear this story about this loving family with no conflict. We got told we were going to hear this story about Carter, Bill, and loving family with no conflict. We got told story about Carter, Bill, and one thing is true. The other one is based on the evidence and in support of that evidence. The state of Iowa requests that you find Jason Carter guilty of murder in the first degree.
I believe we are ready for closing statement on behalf of the defendant, Ms. Branstad.
Thank you, Your Honor. May it please the court? This was a case built against Jason Carter instead of a case trying to solve a crime and look at all the clues. And let's look at all the other leads that weren't followed. There were so many statements made about three individuals who don't have an alibi.
And then the defense's other main point, the video showing Jason Carter and
Rest assured, the state has not had anyone who testified they really killed everybody. No one who says they did it all. But in one of those cases, there's not that window. And it will be mistakes. There's so many evidence in this case. There's so much that isn't even explored. And in reality, the current evidence now makes sense that there's reasonable doubt. The current evidence is Jason Carter to be possible. Children playing practice. Along with their head, Carter and Wealthy was at Wealthy on signal. Now, who would be
as the jury was delivered, state Jason Carter was used to criminal purpose. He said Texas is to the senior sanctions by the it's a better way to do it.
You may be seated, thank you. Ladies and gentlemen,
And so I prepared Jason for the worst possible verdict and Jason Preston.
Evidence and the legal form of the defendant is still powerful. Pursuing and agent workplace will be presented.
Municipal violence, police force in the branch for anyone from the investigated municipality and state. Whatever identity must stay hidden.
About devices that really challenge how we fundamentally think about.
And it's fascinating, isn't it, how this kind of deep dive deliberately takes us, beyond the mainstream perspective to the stories of historical figures, yes, but also modern experiments. People really pushing down, right? They're asking questions that that standard science might think are already answered. We're fascinating. It makes you wonder maybe the whole story that we isn't quite finished yet. This journey into the fringes, that's often where the
And our story with Mike Device starts way back. Stuff. And he's mostly known, if at all, to be one of the first wireless telephone businesses. Imagine that back then. But for us, the really interesting part is his
earth battery. And we're not talking some little classroom experiment. This was a big multi-stranded coil, not on iron, in the ground, and apparently generated a whole bunch of power fun, lights, wireless phone, a whole lot. He also invented a pulse motor, which is
I'm just doing some testing, everyone. I'm trying to get the sound to work with this. I'm trying to get podcast audio to work on StreamYard, so just bear with me.
And it's worth noting, his motors used a mechanical commutator. He created a spark. That detail will come to important later.
Okay, so that brings us to Mike Crow, modern day. Mike, born March 73, so he's 51 now. He really gets going when he starts using 3D around, what, 2012?
Yeah, somewhere around there.
And that was a huge deal for him, right? Suddenly he could prototype parts really quickly.
Precisely.
Oh, absolutely. Hours instead of weeks or months. A total game changer for experimentation like this.
Okay, so here's where it gets really easy. Let's break down the basics first. How does a pulse motor at its core actually work? And what was Mike's sort of foundational approach?
The basic idea is surprisingly simple, almost elegant, but easy to misunderstand. So you've got a wheel, right? Strong magnets on it. As a magnet spins around and gets close to a coil, the drive coil, it passes a little switch, read switch. Okay. That switch closes the circuit just for a moment. Sends power to the coil. The coil makes its own magnetic field and crucially, it's set up to propel that magnet up there. Gives it a bit of shove.
Pushes the wheel along. Exactly. And just as it pushes it away, the circuit breaks again. It's a pulse. And typically, the magnets are north pole facing out. Maybe 4 on a small motor, 8 on a bigger one. Maximizes that push.
Right.
So it's that precise pulse propulsion that keeps the wheel spinning. That's the foundation Mike builds on.
Got it. So he masters that, and then his first big innovation involves this spark gap switch. Now, maybe not everyone listening knows what that is. Can you explain a spark gap switch and what Mike noticed using it compared to, say, regular electronic switches like MOSFETs?
Good question. Yeah, a spark gap switch is, well, pretty much what it sounds like. It's a physical gap in the circuit. Electricity has to literally jump across that air gap, creating a visible spark.
Like a tiny lightning bolt?
Kind of, yeah. Compare that to things like MOSFETs or solid state relays, SSRs. Those are the components. They switch digitally, cleanly, no arc. What Mike noticed was using the spark gap consistently gave him, in his words, a bigger return on power.
More bang for the buck.
Sort of. But his theory is where it gets unconventional. He thinks the spark gap isn't just a switch. He calls it an orifice,
Try not to
an
yell.
opening.
please, Jay.
And through that opening, he believes these things he calls explosive inductive reactions get pulled in from the vacuum or the outside environment, pulled into the system.
Explosive inductive reactance. That's sounds pretty exotic. What does he actually mean by that? And what does he see happen?
Yeah, it's definitely his own terminology, not standard physics. The way he explains it, it's like a form of latent energy out there in space. And the spark, that violent high voltage discharge, somehow allows the circuit to happen to it. The result is, he calls it current-free potential.
Current free potential. How's that work?
Well, normally high voltage means high current, right? Ohm's law, big power drop in your battery.
Right.
But Mike reports that the current run from his battery drops dramatically, like down to microwatt sometimes, even while the coil's magnetic field seems saturated with tons of voltage.
So the battery provides voltage, but doesn't need to supply the current.
That's the idea. He says the battery likes the voltage, but doesn't need the current. So the coil is somehow tapping this other energy source, external potential. And he uses heavy coils. He describes that spark gap as a miniature thunderstorm. So really energetic.
Wow, and that's a massive plan. It challenges basic principles like conservation of energy.
Exactly. It puts his work squarely in that open system category. It assumes circuit.
That it's going through the microphone.
So if the current drops, what's that? Normal coils get hot.
That's the other shock. These coils, despite handling what seems like a lot of power, run cold. He claims they can measure 10 degrees Fahrenheit cooler than the room temperature,
Cooler, not just cold.
which is totally counterintuitive. Current equals resistance equals normal. But with minimal current, you get minimal heat. He even refers to it as a type of superconductivity, suggesting some very different energy dynamics at play.
Mine's slightly blown already. But then he makes what he calls his biggest discovery. January 25th, 2020. And it involves a piezoelectric transducer. First, what's that? And then how to like use it and what happened.
Right. So piezoelectricity, it's a property of certain materials like quartz crystals or special ceramic, barium titanium. Squeeze them, put mechanical stress on them, and they generate an electrical charge. Or apply electricity and they just form.
Okay.
Mike's epiphany, his big idea, was to put a piece of this transducer material in parallel with the drive coil. Plus,
Not the power input, but right across the coil itself.
exactly. He says the effect was immediate and dramatic, with a 40 to 50% gain in power output.
Okay.
Yeah. His load light got 2 or 3 times brighter, and the current dropped from the battery, it dropped even further, basically disappeared. He believes this setup essentially turns the coil transducer combo into an over-unity device, making more energy available than what the battery is supplying.
Someone else confirmed this.
Mentions another researcher, Salvador Paz, corroborated his findings there.
How does he think it works? Why does adding that transducer cause the power surge?
His thinking seems to be that when the coil generates that huge inductive spike, that back kick of energy, piezoelectric material doesn't just react to it, it somehow amplifies their interaction with it to draw in even more of that external energy. He describes it as essentially shorting out the coil, but in a productive way that releases a huge surge of power rather than just dissipate.
That specific placement right on the drive coil. That seems to be leveraging that inductive kick directly.
It seems so, yeah. It's a very novel application.
Okay, so you've got this device generating all this conventional power, like called it dirty transient, more potential than AC.
Yeah.
You can't just plug your toaster into that. And you condition it to use it.
Right, that's crucial. You need to tame it. His method involves 2 steps. First, that raw output goes through a high voltage full wave bridge rectifier.
Rectifier turns DC or pulse the stuff into DC.
Exactly. It converts the chaotic pulses into a form of DC, albeit still very spiky. Then that rectified power gets dumped into a big capacitor. He mentions using like 20,000 microfarads. So serious capacity.
Capacitors smooth things out.
Yeah, they act like a reservoir, absorbing peaks, filling in the valleys, smoothing out those transients, regulating the voltage, sorting out the whole thing.
Something like what Tesla talked about, dumping power.
Precisely. Condenser is just an old word for capacitor. It's the same principle. Once it's stabilized in that capacity, then take it out, convert it to AC rechargeable batteries, or run it through an inverter to get standard AC power.
He emphasizes letting the electricity flow in its most natural state first.
Yeah, he seems to believe modulating it too early interferes with this energy trapping process. He even talks about electricity having kind of consciousness, which is, well, out there.
Yeah. And those voltage readings are wild 960 spikes.
It shows you the kind of transient energy spikes he's dealing with before that capacitor bank smooths it all out.
Okay, so conditioning is key. Now, what about Lenz's law? That braking effect of motors. How does Mike get around that to maintain efficiency? You mentioned voltage.
Right. Lenz's law is always the enemy of motor efficiency. That's inherent correct. Mike's approach is multi-pronged. First, he says, don't be afraid of higher input voltages like 48V or 60, because the actual current draw is so low with the smart gap and coil setup, the total power input remains small.
Okay.
Then the design choices. The smart gap itself is part of it. Also, the core is useful. He uses soft steel, but importantly, it's insular, like individual welding rods coated and packed together, or even birdshot pellets with epoxy. He thinks this helps the magnetic field form and collapse more efficiently.
Less internal drag in the coil itself.
Seems to be the idea. And finally, the timing and spacing of the magnets on the wheel relative to the coil. He talks about making them ride the magnetic wave, keeping a specific distance, creating a null zone or completion zone. Yeah, a precisely timed gap so the magnet isn't pushing too hard against the coil's field as it approaches. This minimizes that direct magnetic opposition, the lens effect drag, and also reduces cogging that jerky feeling you get in some motors.
So it's a combination of electrical tricks and careful mechanical design.
Exactly. All aimed at letting the motor spin freely while still getting that repulsive pulse.
Okay, so if you've got this efficient motor, potentially tapping extra energy.
Yeah.
The next big dream is self, right? Thinking right itself. How do you feed the output power back to run the input without just shorting the whole thing out?
Golden goose. Yeah, Mike talks about breaking symmetry to achieve this. Normally, yeah, just wiring the output back to the input battery is a recipe for disaster and dead short.
Right.
His solution involves taking that conditioned output power after the rectifier and capacitor bank and passing it through another set of bridge rectifiers and capacitors, maybe one or two stages.
Why?
He realizes that this further processing changes the energy characteristics, its frequency signature, its form, something fundamental about it. It breaks the symmetry. Once its nature is altered, it can be fed back to the same input battery without causing a short circuit. It's recognized differently by that.
So you're changing the energy's identity to just fight itself.
That's the concept. It links it to Tom Bearden's idea of open closed systems, essentially tricking a closed and acting like one by manipulating energy.
What does this mean to you? That these things run?
Well, it points towards the potential for autonomous systems that can be self-sustaining. But Mike is clear, getting rid of the starting battery entirely, achieving that classic perpetual motion. That's not quite there yet. You still need that efficient source.
Still needs battery. Which brings us to his battery ideas. He wants a long-lasting battery. And 20 years, maybe carbon graphite or LFP. He also talks about full hot energy.
It is strange from a conventional view. This ties back to that idea of different types of electrical energy. Mike's goal, yeah, is super long life batteries based on carbon design or lithium iron phosphate LFP. But drawing on John Dickinson's research, hot electricity time to use every day, and cold or negative energy, which is cold structure. According to this theory, a battery charged with this cold power needs special treatment to fully discharge it first, then charge it only with this cold energy source, like a TV motor output. Not direct. A cold charged battery supposedly can't be hooked straight up to run a device expecting hot power, or vice versa, without problems.
So how would you use it in the self?
The idea Mike seems to follow is charge a dedicated cold battery with Renegade Device output, condition perhaps, then use that cold battery to power an inverter. The inverter creates standard hot AC power. That hot AC power can then be used to charge the main hot drive battery that runs the motor in the first place.
So the inverter acts as a bridge between the two energy levels.
It creates kind of closed loop, but with this intermediary stage converting cold potential back into usable hot electricity. It really challenges their whole notion of what charge is.
Yeah, it certainly makes you think differently about electricity. And Mike's not stopped there, has he? He's done other experiments. That'd be weird.
Oh yeah, his curiosity is boundless. He talks about something called the end machine, spinning two big, powerful fishing magnets or poles facing out on the same shaft at really high speed, like 4,000 RPM.
What happens?
He says these magnets are like 1,200 pounds lift capacity each, create a visible wrist or tail of magnetic flux shooting outwards. But the really wild claims are about effects near this machine. He talks about potential time dilation.
Time dilation, like slowing down time.
That's what he suggests, affecting both mechanical clocks and digital clocks in space, making them run slower when the machine is operating.
Wow, okay. What else?
He also claims his pulse motors can energize water. Put a glass of water near a running coil, and afterwards, tingling sensation and metallic up. And he's also working on practical stuff, like peg cells for better battery separators. And he's really interested in the EV ray motor, another supposed to suppress high power motor.
Yeah. First battery to time dilation.
Yeah.
It really shows that drive to just more energy. That's
Yeah,
this stuff is impossible.
it really does. It pushes you to wonder, is electricity more complex, maybe even more alive in a sense than we think? Or is there just energy all around us in space that we haven't figured out how to tap properly?
Yeah. Is our current physics model?
Well, that's the question these experiments implicitly ask. Micro, atoms, double wheel, they encourage us not to just dismiss things because they don't fit with current textbooks.
Absolutely. And Mike's whole attitude reflects that. Look, don't just argue about it. He says, sir, get play with it, experiment with it. You'll see the phenomenon. He seems pretty confident that eventually the mainstream will catch up, despite all the skepticism. So, what does this all mean for you listening right now? This whole deep dive into renegade tactics in history. So, wonder and maybe a bit of healthy skepticism about what we think we know for sure. It shows there are claims out experiments suggest efficiencies and phenomena really push the limits of science as we know it. It's an invitation to critically question things and do your own thinking. It's fascinating. Potentially world changing.
Maybe we should do with this important question. If, and it's so big, but if relatively simple tweaks to circuit discard reactor, a bit of crystal there genuinely unlock these mechanisms or cause these strange effects, cold coiling, or even claims of time shifts. Well, what deeper aspects of the energy itself are we still missing? What's waiting just under the surface? And what could finding that mean for everything? Our future power, our understanding of the universe itself.
Okay, guys, that was the end of it. Can you guys hear me okay? Okay, you guys can hear me all right? Okay, good. Sorry, I'm just experimenting. I'm trying to put an audio file into StreamYard. And obviously, I'm trying to work out the bugs to get the best audio sound as possible. So I think because when you do a screen share, it's designed for, say, a video file, but it doesn't give you an option for an audio file. And that's my issue right now. So somehow I got to change the interview into a video file. And if I do that, then I can present it as a screen share and the audio interface thingy will work better. So I'm just kind of toying around with it. But anyways, since I have you guys on, I don't want to make it a complete waste. I got into this thing called, let me pull it up here and then I'll do another screen share. It's called, okay. Let me do a screen share here again. Add to stage. All right, guys can see my screen. Can you guys see my screen okay? I'm using in Windows. I have a PC. I don't have a Mac. All right, so I'm going to show you this. This is what I use to create an interview. So basically, the idea is you go on YouTube and you pull off one of your videos and you copy the actual address of a video. So just like you could pull up any video. Let's see. Let's do one of mine and we'll do somebody else's here. So what you do is you pull up a video like this one here for. Okay, so what you have to do is you want to share it. So it'll come up and it's going to have the address here, if you can see that. So you're going to copy it, right? And then you go into this program called, it's called Google Notepad LM. And what it allows you to do, you will take that address and you plug it in. I won't be able to do it now because I'm at the limit that I can do right now. So I have to buy the plan. They have a special on right now. I think it's pay $0 for 3 months. And then after that, it's $26 a month. But what it does is you put the YouTube video in it and the AI takes over. And what it does, it creates a podcast. All right. And it creates the podcast and comes out as an audio file. So all the content that you had in your video, it will articulate it in a way that it'll have two people in it, a guy and a girl, having a conversation talking about your video. And it'll give all the I was really surprised on the accuracy of what they were talking about because I was listening on specific ideas and comments and how things work and the way they explained it, the way the AI did it. And I was shocked on how well it actually worked. So, yeah, it's really cool. I could create a whole library of content by using the Google LM. So it's a pretty powerful software. Like to take any video you got. So that one there was the interview I did with Nathan about the Renegade. It was the full disclosure. So it reformatted it, put the two characters in there, having the conversation about the Renegade and how it works and all the discoveries I made and how the spark gap works and everything. It even gets into lens law and all this kind of stuff. And it was amazing. I was really surprised how it compiled everything. And it was accurate too. The only thing it screwed up was my last name, how I pronounced it. Kroll. So that's okay. If it screws up my last name, I can live with that. But other than that, everything else was very, very accurate, how it re-represented the entire video. So that's what I kind of been playing around with. So AI is good for something, right? And it helps you create content. I was just kind of shocked on how well it works. So I did 2 of them. I'm going to get this audio thing sorted out. And then after I get that, then I'll probably do more of these podcasts because a lot of people like to play this in the car when they're driving. So they can't look at a screen. Well, might as well just listen, right? Or if you listen to it before you go to bed and, you pop a podcast in, put your earbuds in and, listen to a show before you go to bed. A lot of people do it. I do it all the time. So just some of the stuff I'm working on behind the scenes. I'll be doing more work on the pyramid thing this week. So stay tuned for that. I think I'm going to call it quits now because I just wanted to test this out, see how well it was going to work, if it worked at all, which it sort of worked. Not the best quality audio I wanted, but since I get it, worked out really, really well, I'll play this audio clip again, this audio podcast. Actually, I got 2 of them made. So I'll leave the other one for another day. But for now, just kind of messing around. So anyways, everybody, thanks a lot. And we'll see everybody Friday night, League of Extraordinary Inventors, 9 o'clock Eastern, 6 o'clock Pacific. And yeah, I hope to see everybody there. I see all the regular guys in. That's great. Thanks a lot for your support. And yeah, we'll see everybody Friday. Take care.